बेटा जीमीट की लिंक कल वाली है ना कि चेंज हुई है?
नो मैम, नो सर, कल वाली है।
कल वाली से मैडम आप who is going to do the YouTube live today?
So same, Bhuvi and Sarvagya is doing it.
Okay. Be ready, Bhuvi and Sarvagya. Hello, beta Kushi. Now we can start the program. It's 11 o'clock.
Okay, sir. It gives me immense pleasure to extend to you a very warm welcome on behalf of Research and Development Cell of PC in collaboration with Mathematics Club of PC on the second day of national level webinar on prerequisite for the execution of research work. I would like to welcome each of you for the event. It's an exciting time for us as we continue to grow and adapt. To add more spark to this program, I, Koshiyuki, Vice President of Mathematics Club PC, profoundly welcome Honorable Dr. K.G. Lokhande Ma'am, Assistant Professor, PC Nagpur, Dr. Swapna Ghatoli Ma'am, Assistant Professor, PC Nagpur, Dr. Vishal Shukla Sir, Associate Professor, Sri Ramdev Baba College of Engineering and Management, Nagpur. Also, our overwhelming welcome to Dr. Mrs. A. Kulkarni Ma'am, HOD of Mathematics, Co-Convener Dr. Girish Mehta Sir, Co-Dean Research and Development Cell PC, Convener Professor Satish Tiwari Sir, in charge of Mathematics Club PC, Co-Convener Professor Praveen Jadhav Sir, Secretary Dr. Subhash Bagmare Sir, Professor Manisha Pun Ma'am, Professor Sweetie Rokde Ma'am, Professor Kunal Modak Sir. I also welcome the deans and HODs of various department and invited faculty, research scholars, industry person, and all the participants. Moving further, let me quickly introduce you all to the agenda of today's event. We will be having session of an hour with all of our guest speakers with a question and answer round at the end of each session. Today, we are having 3 resource persons with the first lecture of Dr. K.G. Lokhande Ma'am. She is going to make us understand the optimization of mathematical models, statistics, and reliability concept in research process. The second lecture is of respected Dr. Swapna Ghatoli. She is going to guide us about the field database modeling, a case study on sieving machine operation. The third lecture is of Dr. Vishal Shukla Sir. He is going to deliver a lecture about the research avenues in the product lifecycle management. I hope all of you stay tuned till the end and get drenched in the sea of learning. Reliability, modeling, prediction, and optimization present a remarkably broad framework for the analysis of technical and commercial aspects for product reliability, integration concept, and methodologies from such diverse areas as engineering, material science, statistics, probability, operation research, and management. To know more about the topic, optimization of mathematical models, statistics, and reliability concept in research process, I would like to invite respected Dr. K.G. Lokhande ma'am, Assistant Professor, PCE, Nagpur, to share some knowledge with us. She completed MSc in Statistics and PhD awarded by RTMNU Nagpur. Her area of specialization is Operation Research with 22 years of teaching experience. Her 6 papers were presented at international conference and 12 papers published in international journals and 3 papers in the Scopus Indeed journal. And she delivered 15 lectures on syllabus and research methodology. Ma'am, please.
Hello.
Yes, ma'am.
Thank you, Kushi. I'm sharing my screen, just wait for.
Yes, ma'am, yes.
A very good morning to all the dignitaries and all the attendees of the workshop. Am I audible?
Yes, ma'am, you are audible.
So a very good morning to all the dignitaries and all the attendees of the workshop. Let me first congratulate and thank the organizers for giving me opportunity to be one of the speakers. Thank you, Mehta sir. Thank you, Tiwari sir. The topic which I am going to talk about is optimization of mathematical models, statistics and reliability concept in research process. This lecture presents optimization of mathematical models, the overview of various statistical tools and probability distributions that can be used to analyze the data. Though various software are available for analysis of data, it is an imperative to learn and understand all the tools and then turn to software. This will enhance the understanding of process and make the researcher aware of what is being done with data. Now, this is a very good example to understand why it is necessary to choose proper measure. Otherwise, what can happen?
Hello. Ma'am, sorry, ma'am, but the screen is not visible, ma'am.
Wait a minute.
Yeah. Sure.
Is it visible now?
Yeah.
So coming to this. So this is very good example to understand why it is necessary to choose proper measure. Otherwise, what can happen? See here, on a swimming pool with increasing depth ranging from 3 feet to 7 feet, on a board it was mentioned average depth is 4.5 feet. A boy with height 5 feet jumps into the pool and see what is happening. So here it is very necessary to choose a proper measure. Otherwise, you may come across with this type of situation. Okay. Now, if you are dealing with database research, then your data can be logic data based, Your research can be logic data-based, experimental data-based, it can be field data-based, it can be on the basis of data generated through design of a system, or based on the data collected by earlier investigator. So if we are to fit model to data, questions arise are, what kind of model should we use? How does model reflect our goals in modeling process? To answer these questions, following are some common modeling tools. Fitting of polynomials, fitting of regression models can be linear or nonlinear, and fitting of stochastic distributions. To understand fitting of polynomial distribution, we are considering a very simple example. Suppose that if you wish to fit a polynomial of the type, say y equal to ax square plus bx plus c to the given data. You have data for x and y. Then following are the normal equations which are to be solved just to fit the data just to fit the equation to the given data. Okay. Now this type of problem can also be solved with the help of MATLAB inbuilt function. Just you have to give x array, y array, and give one command coefficients polyfit x, y, and if you wish to fit a polynomial of degree 2, just give here 2. It will return the coefficients of the values, that is a, b, and c, and hence the least square quadratic equation which is to be fitted to the given data is of this type: y equal to 2.5 plus 2.5214x plus 1.8214x square. So how to generate these normal equations is very easy task that can be understood very easily, but you can just, and this particular thing can be done with the help of Excel also. On Excel, if you give your data and you just ask for trend equation, it gives you the trend equation. So this can be done by using MATLAB or can be done with the help of Excel also. Now once you fit the model, the validity of that model can be tested by finding the standard error of estimate, and we can find the coefficient of determination. Here, coefficient of determination formula is r square is equal to st minus sr upon sr, where sr is sum of squares of residuals, which is obtained by using this formula, which is also known as error sum of squares. Now, if the value of r square is close to 1, it indicates the perfect fit. Then we move to regression analysis. Regression analysis is widely used to derive the relationship between dependent and independent variables for prediction and forecasting. Now, a nonlinear regression is sometimes used to fit a large variety of curves to data. Fitting of multiple regression. Let us understand how do we fit this multiple regression. See, if we have only one dependent and one independent variable, we can go for polynomial fitting. But if you have more than one independent variable, you have to think about multiple linear regression. Suppose that you are fitting a regression of the type, equation of the type y equal to a plus b x1 plus c x2. Here we have limited our variables up to independent variables to 2 only, just to understand the process. To fit a least square regression plane to the data, these are the normal equations which are to be solved. Again, these normal equations can be easily understood how to generate this. Again, this can also be solved by using MATLAB. Just by giving these two commands, give the summations in first command, then some second summation in second command, and then give the command that x is equal to a slash b. It returns values for a, b, and c so that you can fit the required equation to the data. Again, to understand, we have here data corresponding to x1, x2, and y. In MATLAB program, if you give a, b, here under a, you are giving the values of summations and b, and then you can just put the command x is equal to a slash b, which gives the output a equal to 7, b equal to 3, and c equal to 4. So this gives us the equation of best fit as y equal to 7 plus 3x1 plus 4x2. If you can't obtain an adequate fit using linear regression, then you can choose a non-linear regression. In engineering, most systems are inherently non-linear in nature. To reduce the complexity of model, it becomes necessary to reduce the number of independent variables. The most commonly used methods of reduction of independent variables are dimensional analysis, principal component analysis, and cluster analysis. What we do in dimensional analysis, here we combine the variables by taking ratio of 2 or more quantities to make the term dimensionless. What we do in principal component analysis, here we compute the scatter matrix, that is variance covariance matrix, and then we find eigenvalues and eigenvectors of that matrix. Then we choose eigenvectors with the largest eigenvalues to form the k-dimensional matrix. Then use these k eigenvectors to transform the sample into new subspace. So you can use here also you can use inbuilt function PCA class from the matplot library just to reduce the number of independent variables. Because dealing with large number of variables again increase the complexity of your research. So you need to reduce the number of independent variables, and that can be done with the help of either with the help of dimensional analysis or with the help of principal component analysis, or you can use cluster analysis also. Now what we do in cluster analysis, we calculate the correlation coefficient. Then the variables that correlate highly with one another are kept in one cluster, and comparatively low correlations with variables in the other cluster. This is how we can form the cluster, and then we can reduce the number of variables. Now in dimensional analysis we take ratio, whereas while applying principal component analysis or cluster analysis we take linear combination. So if your data is from normal distribution and if you are taking ratios of the variable, then it may lose its generality, and because we know that if x1 x2 follows normal distribution, and if you take a ratio of x1 and x2 it will not follow normal distribution. Whereas the second and third method, where we take only linear combination of the variables to reduce the number of variables, then according to property of normal distribution, that if you just add the normal variates, again the resultant variable also follow the normal distribution. So if you don't lose the information, you can go for second or third method for reducing the variables, independent variables. Now question is how to fit nonlinear regression to the given data. After collecting data and going through dimensional analysis or principal component analysis or cluster analysis, then the terms that you get can be written in the form of pi1. This pi01 left hand side denotes the dependent variable, where on right hand side we have independent variables pi1, pi2, pi3, pi4, pi5 and pi6. We have written here nonlinear model for output variable pi01 in terms of pi1, pi2, pi3, pi4, pi5 and pi6. Now to find the values of this k1, a1, b1, c1, d1, e1 and f1, what we do, we first linearize this model by taking log on both sides, so that we are with linear model z is equal to k1 plus a1 into x1 and so on up to f1 into x6. Now again, to find the constants involved here, we have to go through these normal equations. We have to solve these 7 normal equations so that we can find the values for k1, a1, b1, c1, d1, e1 and f1, those values for which error is minimum. Here actually to generate these normal equations, method of least square is used, which minimizes the error in observed and expected values. Again, generation of this normal equation can be easily understood. Now here we find those values for k1, b1, c1, e1, d1, e1 and f1 for which this error between observed and suppose that z is equal to k1 dash a1 dash into x1 plus b1 dash into x2 up to f1 dash into x6 with the equation of best fit.